All right, let's talk about something anyone who's used an AI has bumped into. Hallucinations. You know, those moments when a chatbot just confidently makes stuff up. We're going to dive deep into this, because it turns out these aren't just random glitches. They're actually a totally predictable result of how we're teaching these AIs in the first place.
I mean, you've been there, right? You ask a pretty simple question, you're just looking for a fact, and the AI comes back with something that sounds completely reasonable, but it's just dead wrong. It's super frustrating, and honestly, it kind of makes you wonder if you can trust these things at all.
So check this out. This is a real example from a research paper. They asked a top-of-the-line AI model for the birthday of an OpenAI researcher, Adam Kalai. First shot, it says with total confidence, 0307.
Okay, but then they ask it again, the exact same question, and this time it spits out a completely different answer. 1506. You can already see what's happening, right? It's just throwing darts at a board. It's guessing.
And on the third try, it comes up with 0101. Now, the wildest part is that the paper says his actual birthday is in the fall, so not even in the same season. The AI has absolutely no idea, but it would rather lie 3 different times than just say so.
So yeah, these confident lies, that's what we in the field call hallucinations. And this isn't just a problem for some little open source models. Nope, this problem runs deep, even in the biggest, most advanced AIs out there.
Let's just be super clear on what we mean by that. A hallucination is when an AI gives you something that sounds plausible, but it's totally made up, factually wrong, or just nonsense. And the key is, it serves it up to you like it's gospel truth. It's not just a mistake, it's a full-on fabrication.
Now, this is where it gets really interesting. The main takeaway from the research we're looking at is this: hallucinations are not a bug. They're not some mistake in the code we can just go in and patch. They are a learned behavior, something we are actively teaching the AI to do.
The best way to think about it is like this. We've basically created an education system that trains AIs to be the absolute worst kind of student. You know, the kind who figures out it's always better to just scribble down a wild guess on a test than to ever leave an answer blank. And to really get why this happens, you have to look at the AI's schooling in 2 big stages. First, you've got pre-training. That's where it just gobbles up the internet to learn how language works. Then there's post-training, which is all about getting it to pass the tests we give it. And, as we're about to see, both of these steps are part of the problem.
Okay, so let's start with that first stage, pre-training. This is where the AI is just swimming in a giant ocean of text, learning grammar, facts, and all the statistical connections between words. But the way it does this actually sets the stage for making things up. At its heart, the AI is just trying to solve what the researchers call the "is it valid" problem. It learns to tell the difference between sentences that seem statistically likely, like "there is one N in piano," and sentences that are just wrong, like "there is one G in cat." And this gets to a really fundamental point. The model is a probability engine. It's all about what's likely to come next. So even if you fed it nothing but perfectly true information, the sheer statistical pressure to create sentences that sound right means it's bound to generate errors. It's not a garbage in, garbage out problem. It's just baked into the process. But if that's where the problem starts, this next part is where we pour gasoline on the fire. Stage 2, post-training. This is where we fine-tune the model and grade its performance, and it's here that we actively and frankly disastrously reward the AI for guessing. I mean, just look at how we're grading these things. It's the whole problem in a nutshell. If the AI gets an answer right, it gets a point. Great. If it says, "I don't know," it gets a big fat 0. But if it just takes a wild stab in the dark, well, it might get lucky and snag that point. From the AI's point of view, guessing is always the best move. There is 0 reason to ever admit it doesn't know.
The OpenAI researchers who wrote this paper absolutely nailed it. They said our current methods create an epidemic of penalizing uncertainty. We are literally, systematically training our AIs to believe that saying "I don't know" is the same as failing.
And don't think this is just some minor issue. We're talking about the big leagues here, the most popular, most influential benchmarks. The tests we use to decide which AI is the best all have this same broken system. MMLU Pro, GPQA, SW Bench, every single one rewards guessing and offers nothing for admitting you don't have the answer.
So, okay, that sounds pretty bleak, right? We're the ones teaching the AI this terrible habit. But that also means we should be able to unteach it. And here's the good news. The fix is surprisingly simple. Here's the new report card. We just make one tiny change that makes all the difference. A correct answer still gets 1 point, but now a wrong answer gets -1. We penalize it, and I don't know, that stays at a neutral 0. All of a sudden, the entire calculation flips. It's now way smarter for the AI to just admit it's clueless than to risk getting a penalty for being wrong. I love how one commentator put it. The whole goal of this is to teach the AI the humility to shut up. It's about making the AI's goals the same as our goals. We don't want an AI that's good at acing flawed tests. We want one that's honest and reliable. So what does all this actually mean for us, the people who use these things every day? Well, making this one simple change to how we grade AIs could have a massive, positive impact on how they behave in the real world.
It means we'd see a lot less misinformation being passed off as fact. It means the AI assistant in your phone or computer would be genuinely more trustworthy. And, maybe most importantly, it means we'd finally be building an AI that has one of the most critical forms of intelligence, knowing what it doesn't know.
And that kind of leaves us with this final thought. When it really comes down to it, what do we want from our technology? Do we want an AI that pretends to be all-knowing? Or do we want one that's honest enough to tell us when it's out of its depth? The choice, and the power to build that better AI, is actually ours.